Hi students. Today we are going to discuss about theory related to finding the effectiveness or efficiency of a screen. It is very important whatever the screen we have, how good it is separating bigger sized particles and smaller sized particles. What is the primary objective of the screen is to separate bigger particles greater than the diameter of the screen, and the screen has to allow the smaller particles to go through it or to the next screen. When the screening is perfect, the efficiency of the screen will be 100% or effectiveness of the screen will be 100%. In reality, the effectiveness will not be 100% because of the many factors. Sometimes the screens might, the wires which is made of screens which are made of wires might have damaged. What happens if the wire got damaged? The bigger particles which is greater than that of a screen can able to pass through. This is first, because the primary objective is to stop the bigger particles, right? And if it is allowing the bigger particles also to pass through, then the effectiveness won't be 100%. And the other way, imagine the smaller particles. What is the job of the screen is to allow the smaller particles to go through it, but sometimes it will not happen because there might be blockage of the screen diameters, because of the bigger particles might have sit on the smaller, on the screens. Because of that, the smaller particles don't find any spaces to go through it. So bigger particles will be passed through it, the screen, smaller particles will remain on the screen. If this kind of situation comes, the effectiveness will not be higher. That means close to 90%, 80% will not be happen. The effectiveness will be less than the 100%. In reality, this is the situation. Today we are going to discuss about the same topic of finding effectiveness of a screen using some mathematical concepts. In the next subsequent video, we are going to do the practical in the lab on finding the effectiveness of a screen. Okay, let us go to the board. Okay, students, let us go ahead the theory behind finding the effectiveness of a screen. Before we go into the deeper details of finding the effectiveness, let us see what the screen does. What is ideal screen does? Based on that, how we can judge what is in reality the screen is. So if you see on the board, the is talking about the ideal screen, means that it should be ideal. That means this is what screen should do. Okay, imagine there are bigger particles and smaller particles. Bigger particles are called oversize and smaller particles are called undersize. F is the field. Okay, this is the screen. Okay, what is the screen? When you put the feed into the screen, the bigger particle should stay on the top, which is called oversize, and the smaller particle should come to the bottom, which is called undersize. So this is the people terminology will use. The one which is putting into it is called feed, and the whatever the thing that is remained on the top is called overflow. Whatever the thing that is coming to the bottom, it's called the underflow. In the overflow, there has to be only bigger sized particles. In underflow, it has to be only smaller sized particles. If you see, it is beautifully separated. All the bigger particles comes onto the D, which is called overflow. All the smaller sized particles come to the bottom, which is called the underflow. This is what the ideal screen should do. And if we find such cases, then the screen effectiveness or efficiency equal to 100%. What is in reality happening? Real, that means in reality, or non-ideal screens. If you put the name of non-ideal screen, if you put the feed into the screen, same feed, if you put it to the screen, and all the bigger particles you can see on the top, as well as the smaller particles are also there on the top. You can see ideally what it should do, all the bigger particles should come on the top and all the smaller particles could come to the bottom. But see, After the screening action, you find bigger particles as well as some smaller particles are there on the overflow, and at the bottom also you will see smaller particles as well as the bigger particles you can see in the underflow. This is what the non-ideal screen looks like. Let us define, if you find cases like this, the effectiveness will not be 100%. And let us see the terminology. All the particles is termed as a feed. All the particles stays on the screen, which is called D, which is called overflow, and all the particles stays at the bottom, which is called the underflow. Okay, what is that is called F, D and B. Let us see what is XF. XF is among the particles how much are bigger, that is. And what is this? XD is denoting the fraction of oversized particles in the overflow. What is XB? XB is the fraction of oversized particles in the underflow. XF, XB and XD are talking about the bigger size particles. And 1 minus XF means, so 1 minus XF is the amount of smaller particles in the feed. 1 minus XD is called amount of smaller particles in the overflow, and 1 minus XB is the amount of smaller particles in the underflow. So this is the main terminology we use, okay, and that is what is defined on the board. XF is the fraction of oversize, XD oversize, XB is oversize, and 1 minus XF is the undersize, 1 minus XD is the undersize, and 1 minus XB is the undersize. This is the feed, overflow and underflow particles, oversized particles and undersized particles. And here let us define how to define the effectiveness of a screen. What is the job of a screen? It should, all the bigger size particles should be at the top and all the smaller particles at the bottom. That is called recovery. Recovery means it's talking about our product. Imagine I have given screen effectiveness based on oversize. That means this blue color balls, example, these are the bigger size particles are our product. Okay. Imagine, in some cases, smaller size particles will be your product. So in all this today's lecture, we are assuming that our bigger product is oversized. That means bigger size is our product. So our objective is to separate the bigger size from the smaller size. So what is effectiveness? Let us come back to the definition. What is effectiveness? Is recovery into rejection. What is recovery? Recovery is very simple. We are putting these many particles of oversize here, right? If all particles comes to the top, then recovery is 1. These are the smaller size particles. If all particles comes to the bottom, smaller size particles, then rejection is 1. That means this screen is efficiently separating recovery of oversize and rejection of undersize. If both should be 1, that means recovery into rejection. It should be recovery is 1, rejection is 1, my effectiveness will be 1, which is 100%. What is the recovery? D into XD. D into XD means in the overflow, how many bigger size particles are there? Okay, that is called D into XD. What is F into XF? How much I have bigger size particles I have kept on the screen as a feed. That means if all the feed comes to the overflow, all the bigger size particles in the feed comes to the overflow, that means this ratio is 1. 1 minus XB into XB divided by 1 minus XF into XF. 1 minus XB means smaller size particle, right? What is 1 minus XB into B? That means this is 1 minus XB. Example, this is 1 minus XB, means amount of smaller size particles in the underflow. If all the particles came to the underflow, all the smaller size particles came to the underflow, that means this ratio will be also equal to 1. What is 1 minus XF into 1 minus XF into F means this one. Amount, whatever I have kept, the smaller size particles, everything has come to the bottom, means I have successfully rejected the smaller size particles. That means this ratio is also equal to 1. When it is efficiently separating bigger size and efficiently separating smaller size, that means my recovery into rejection is 1. That means in such cases my effectiveness or efficiency is 100%. In reality it is not so. So we have to find out, right? So this is if you multiply these two, then E equal to effectiveness xd into 1 minus xb by xf into 1 minus xf d by f and b by f. That means in the further derivation I have to get some expression for d by f, I have to get some expression for b by f. Once I put here, I get a complete expression that if I know xb, xd and xf, I can able to calculate the effectiveness or efficiency of a screen. So let us move further about the derivation. Hi students, let us go through the derivation. To get an expression for d by f and b by f, and we have to do two things. One is overall mass balance and second is oversize balance. So that is why the theory starts with the overall mass balance, means how much amount of feed we are putting in, how much amount of product that is coming out at the top and how much amount of the reject is coming at the bottom. F equal to D plus B. That's called the overall mass. Overall mass consists of bigger size particles as well as smaller size particles. And the second balance is the undersize component balance. The undersize, oversize component balance. Component balance means now I'm not talking about the total mass, I'm talking about the only bigger size. If xf is the fraction of oversize, f into xf is the amount of oversize. So f into xf, that is amount of oversize that is going in as a feed, it is coming out as a product. Product means overflow. D into xd is amount of bigger size particles in the overflow. B into xb, amount of bigger size particles in the underflow. So if you do the balance, f into xf is equal to d into xd plus b into xb. So when you do the mathematical calculations, take this, we replace this b with f minus d. Okay, once you replace b with f minus d, you get fxf is equal to d xd into d plus xb into f minus d. You simple. After this, you common out the f on one side, d on the other side. You get this expression, d by f is equal to xf minus xb by xd minus xb. Similarly, from the same equation, now take out d, okay? D equal to f minus b. Simple. You replace wherever you see, d, you replace with f minus b. So again, fxf is equal to xd into f minus b plus xb into b. If you do this, you get shift f on one side, the b on another side. Then you get the ratio b by f is equal to xf minus xd by xb minus xd, or if you multiply numerator and denominator by minus and minus, you get xd minus xf by xd minus xb. Okay. Once you get the expression for d by f, and once you get the equation 5 and equation 7. Okay. If you remember this, the earlier board, E equal to, we get some expressions, right? Simply we have to substitute and d by f and b by f in place of effectiveness, and you get this E equal minus xb by 1 minus xf into xf minus xb by xd minus xb, xd minus xf by xd minus xb. You can see now xd minus xb, xd minus xb, xd minus xb whole square. Okay. So if you rearrange this equation, the effectiveness factor is xd into 1 minus xb into xf minus xb into xd minus xf divided by xf into minus xb whole square. Now we got the complete expression for finding the effectiveness of any screen. Only one thing you should know, what is the amount of xf, xb, xt. These are the three things you should know. What is xf? Amount of oversize in the feed. xd, amount of oversize in the overflow, and xb, amount of oversize in the underflow. So let us do the small example. Calculate the effectiveness of a 30 mesh screen. Let us say we have taken an example. I am interested in finding out the effectiveness of a mesh number 30. Calculate the effectiveness of a mesh number 30. If the fraction of oversize in the feed, overflow and underflow were given as 0.326, 0.398 and 0.004. That means they have given that what is XF, what is XD and what is XB. Simply you substitute this XD, XB, XF in the formula which is written number 8, and you're going to find effectiveness of a 30 mesh screen is 0.264, or percentage effectiveness is nothing but effectiveness into 100, which is called 26.4%. That means this screen can able to efficiently do its job only up to 26.4%. Efficient in most of the cases. That's what this means is. Then the important aspect is how I got this number. XF is equal to 0.326, XD equal to 0.398 and XB is equal to 0.004. For this, I have conducted one experiment in the lab and I have uploaded in the name of effectiveness of the screen demo practical. Okay, if you could able to watch the video, then you can get an idea how I got these three numbers. So it will be more clear. Okay, thank you.